The topic of the video is parity or space inversion operator. The spatial reflection about the origin of a coordinate system is called parity operation, and the parity operator, which is denoted as p hat, is defined as p acting on some state function psi of r will transform it to the state function at psi minus r as equation number 1. And if you operate the operator p on equation number 1 one more time, on the left hand side we get p square acting on psi of r, and on the right hand side when p acts one more time and on psi at minus r, it will take you to psi at r. So you can write that p square is equals to I, or p into p is equals to I. Since p into p inverse only should be equal to I, we can write p inverse is p itself. And I'm not giving the proof here, but parity operator is also a Hermitian operator. That's because if we compute these brackets of p phi psi and psi with p psi, I mean phi with p psi, the answer will be same. So we can say that p dagger is equals to p, so p is Hermitian operator. And p is also unitary operator. That's because we already knew that p inverse is equals to p, and then p dagger is equals to p, so we can write p dagger is equals to p inverse. Therefore p is a unitary operator. Eigenvalues of operator p. If you consider eigenvalues of operator p as small a for eigenfunction psi of r, then we can set up the eigenvalue equation as equation number 2. And on that, if you act the parity operator one more time, on the left hand side it will become p square acting on psi of r is equals to a into p acting on psi. And since p psi is equals to a psi again, so on the right hand side we get a into psi, and on the left hand side p square is equals to I, so we get I into psi of r is equals to a into a into psi. Therefore we can write a square is equals to 1, or a is equals to plus or minus 1 as the eigenvalues of parity operator. If the eigenfunction of the parity operator p for eigenvalue plus 1 is taken as psi sub plus and r, then the eigenvalue equation can be p acting on psi plus will give you plus 1 into psi plus. But on the left hand side, when p acts on psi plus r, it should be taking it to psi plus at minus r. So the above equation will become psi plus r is equals to psi plus at minus r. That means your psi plus function should be even function. And next, if the eigenfunction of the parity operator for eigenvalue minus 1 is psi minus r, then the eigenvalue equation is that if p acts on psi minus, it will be taking it to minus 1 into psi minus. But by definition of the parity operator, if it acts on psi minus, then it should be taking it to psi minus at minus r. Therefore the above equation can be written as psi minus at minus r is equals to minus 1 into psi minus r. That means your psi minus psi sub minus should be odd function. Intrinsic parity. The eigenvalue equation for parity operator is also written as I'm sorry for that. Eigenvalue equation is written as p psi is equals to plus or minus exponential I phi by 2 into psi, where this phase factor exponential I phi by 2 is called intrinsic parity. That's it in this video. Thanks for watching.